So for number 3, I had to plot a distance versus time graph for 2 periods of motion with the spring. So yeah, here's the graph right here over 2 periods of time. I just copied and pasted it from my Excel. So here is my distance over time graph. I've got my period in seconds, which I just used the answer I got for the k value, that 1.50131 right there. Yeah, so I used 2 pi times the square root of the mass over the k value, which is the equation for period. And then I have 0.125 meters as the max distance because we were given 125 millimeters. Then I calculated omega, which was just 1 over the period, so the frequency times 2 pi, and got the 2.45. And I don't know why, but I decided that I also needed the amplitude, which is the same as the as the distance. And I also had 2t because I used that just to figure out how far down I should go, which was right there. For my time, I started with 0 and then made this complex thing where I took the previous time and added the period value over 32. But I had to write it as the period function, not as g1, because if I did that, then I couldn't just drag and click all the way down to fill in the same formula over and over again. Like so. And then for the distance formula, I started trying to write it like this, where I would do the amplitude times cosine of omega times whatever is in the time slot. But I quickly ran into problems, and around number 5, I had realized that it was best to write everything out all the way except for the A column, because that way I could just drag and scroll all the way down. The reason I chose 32, or over 32, was because I figured a lot of dots would make a more precise graph. I know it did not need to be that much, but I just thought it looked nice, and yeah, I think that's about it.